Okay, so knowing that, this is a part of the semantic memory. Semantic memory is your knowledge for general knowledge, and we can talk about the structure of semantic memory and the function of semantic memory in this particular video. Well, like as usual, this is a big picture. We covered all the pieces of the puzzle. Now we are in this last fourth piece, the memory. And we're talking about the long-term memory here. Again, long-term memory is further divided into declarative and non-declarative memory, but we are specifically talking about the declarative memory that is conscious to our experience and that you can talk about, as opposed to the non-declarative memory or procedural memory or implicit memory, which it is difficult to talk about, or it actually used without bringing it to consciousness. Okay, so in this video we're gonna be focusing on episodic and long semantic memories, and more specifically semantic memories. So to kind of give you a visual representation, we classified using the usually used taxonomy the long-term memory into declarative memory. It's also called explicit memory, and the non-declarative or implicit memory. This is the memory that for procedures like your habits, skills fall under this category. The declarative memory, which is also called the explicit memory, declarative memory because you can talk about it, and explicit because it comes to your awareness when you access that information. Now, depending on the content of this declarative memory, we have two kinds of declarative memory: episodic and semantic. Episodic memory is a memory for personal experiences, and semantic memory is the memory for general knowledge. And for this video, or in this video, we'll specifically talk about semantic memory. Well, an important question is, why only semantic memory? Well, to start with, what applies to semantic memory for the most part, at least in terms of the structure and processing information, equally applies to the episodic memory. But there is another reason why we specifically want to talk about semantic memory. Remember, we are trying to figure out and solve the puzzle, which is how we comprehend a written text, which inevitably involves language. And semantic memory and language are interconnected in the sense that for you to use in language, you need to use the language, the knowledge base, and the knowledge base that we use to actually use language is the semantic memory. So that's one reason why we are concentrating more on semantic memory as opposed to the episodic memory. Now, when we talk about semantic memory, right, we'll talk about two different aspects of it. We'll talk about the structure of the semantic memory and the processing of semantic memory, specifically in the context of one of the models. Okay, again, we'll talk about the structure of the semantic memory and the processing of semantic memory, of information in semantic memory. Well, there are two types of semantic memory. Semantic memory 1, which is your memory specific to conceptual knowledge about concepts, apples, books, humans, whatever it is that you have concept of, which is an important part of your semantic memory, is semantic memory 1. The semantic memory 2 is a situational knowledge. It's a knowledge you have, a general knowledge you have about different situations, like how to behave when you go to a dine-in restaurant, which is different from how you behave when you go to a drive-through restaurant. So this knowledge, this is again a general knowledge about situations, so it's called situational knowledge. The conceptual knowledge is a general knowledge about the concepts. It involves not situations, but different concepts. Now, the structure and the way we process information is same for both conceptual knowledge and situational knowledge, semantic memory 1 and semantic memory 2. But we will discuss the structure and processing information in the context of conceptual knowledge. So you're doing two things at the same time. You're knowing what conceptual knowledge is, you're also knowing the specifics of the structure and processing of information specific to conceptual knowledge. But keep in mind that it equally applies to situational knowledge. So to visually represent what I just said in the previous slide is basically we are looking at semantic memory. And there are two types of semantic memory. Semantic memory 1, which is conceptual knowledge, and semantic memory 2. What is it called? Can you retrieve? Yes, that's the situational knowledge. So we'll talk about these two things. And we'll talk about the structure and processing aspect of the semantic memory, which applies to both SM1 and SM2, but we'll discuss this in the context of SM1. Now, I want you to keep in mind, structurally, we'll be using terms like concepts, and there's another term. Again, we'll come back to this to fill this information in together. And when we talk about processing information in semantic memory, we'll talk about concept activation and two other things. Again, we'll fill this as we go. Okay, so semantic memory 1 is the conceptual knowledge. This has information about different concepts that you've learned. And if you think about it, your conceptual knowledge is like a mental dictionary. Have you ever tried to access a online dictionary? Well, in an online dictionary or any dictionary as such, when you look for the meaning of a word, it is defined in terms of other words. And if you look for the meaning of that other words, again, it is defined in terms of the words that already exist in the dictionary. It's like a never-ending loop. The idea here is that your conceptual knowledge is also a network. Your conceptual knowledge is also a network of different words, and these different words are basically concepts. So in that sense, your semantic memory is a mental dictionary of meaning, right? How do we create these concepts of the mental dictionary? Well, if you remember, we extract meaning from our common experiences. Like you have experienced dog, and you've experienced a different dog. You've experienced a third dog. So you kind of assimilate this information or put together this information and extract what is common across these concepts, and then you have what is common across these experiences, and then you have this concept of dogs. So anything that has these features then belongs to this particular concept. So what is the utility of this? Well, the utility of concepts is that when you experience or when you encounter a new similar object, a new object or event or experience, then you can easily categorize it as belonging to that concept as opposed to coming up with a new concept. So it kind of simplifies our lives so that each and every time we experience an object that is kind of similar to what you've experienced before, you're just categorizing it. So remember, it's a part of perception, categorizing an instance, an object as just one instance of a bigger category of things. Well, if conceptual knowledge is a general network of these concepts that you have developed, right? Well, by connecting different concepts, you can also kind of create knowledge base specific to general knowledge about, okay, who is the first president of the United States? Well, this is basically a combination of concepts, the first president, United States, and whoever it is. So you kind of have this network of concepts that forms a basis of your mental dictionary, but also it forms the basis of your knowledge of the world, the general knowledge of the world. In that sense, your semantic memory is also a mental encyclopedia. So, so we said that semantic memory is a network of concepts. So we'll talk about this semantic memory. It equally applies to both, but we're specifically talking in terms of semantic memory one, which is a conceptual knowledge. So we're going to talk about the structure and process of semantic memory. Now, there are several models that are proposed to explain what the structure and of the semantic memory would be like and how we process information. But there is one particular model that's most influential, and that's what we will talk about now. It's called the semantic network model. So one of these semantic network models, or the first one to be more precise, was proposed by Collins and Quillian. And along with Loftus, of course. This is called the Collins and Quillian and Loftus model of semantic memory network. Now, the idea here is that according to this theory, your semantic memory, the conceptual memory, of course, it equally applies to the other memory, but the conceptual memory for sure, is a network of concepts. So you have Robin, you have bird. So you know that Robin is a bird. So these two concepts are connected. We know that Robin lays blue eggs. So this blue egg and Robin are also connected. We know that bird can fly. So fly, the concept of flying is connected to bird. The concept of feathers is connected to birds. The concept of animals is connected to bird, and so on and so forth. So your semantic memory then, conceptual semantic memory one, is a network of these different concepts. So you can think of semantic memory as an interrelated set of concepts or interconnected set of concepts or a network of concepts. Now, when you have a network of concepts, there are two terms we use here. One is the node, and the other one is the pathway. Node refers to the points or locations in the semantic space. This is called the semantic space. And basically a concept is also called a node. And what connects these concepts are these lines, right? These are called pathways. What are these? Well, these are associations between different concepts, which will determine the kind of relationship between two concepts. For instance, you say Robin has red breast. So this particular line or pathway determines the kind of relationship this concept has with this concept. Now, if you look at it, it's called P. Okay, we'll come back to this in the next slide, but which is different from this particular pathway here, which is the connection between this concept Robin and this concept bird. You cannot say Robin has birds, like you can say here Robin has a red breast. You cannot say that. So the kind of connection here is called an either connection. Again, we'll talk about in a second in the next slide. But basically the idea is that the pathway here is different from this pathway. In other words, the pathways, which are the connections between any two concepts, are associations between concepts that are labeled. Labeled here is one is labeled as P, the other one is labeled as easy, and we'll talk about what this means in a second. And these are directional. In other words, that you can say Robin has red breast, but it cannot say red breast has Robin. So the connections, the pathways are directional. Similarly, you can say Robin is a bird, but you cannot say bird is a robin, because that's not an accurate statement. So these pathways are labeled directional associations between concepts. Now, when you say it's a network of concepts, as you already know, proposition, right? A proposition is basically two concepts and a pathway. Two concepts and a pathway will make one proposition. It is a relationship between two concepts. Like for instance, if you say, when you say Robin is a bird, that is a proposition that has two concepts, Robin and bird, connected by a pathway, which is a pathway. Okay, so what is a proposition? You already know that it's an idea unit. Robin is a bird is a single, simple idea unit. That's what propositions are. These are truth statements in the sense that these are either true or false. Now, you can think of semantic network or the semantic memory We are talking about conceptual memory here, so it applies to other one also. But the semantic memory one then can be defined as, well, structurally, semantic memory is a network of concepts. Well, remember, any two concepts with a concept with a connection is a proposition. So you can also think of semantic memory as a network of propositions, right? So what is a proposition then? Well, as we said, proposition is an idea unit. It's the truth statement. It is a relation between two concepts. Now there are two kinds of um, propositions based on the type of pathway. Remember, there are two types of pathways. P stands for property pathway. ESA stands for membership pathway. Well, why it's called property pathway is that this particular connection is showing the property relationship between these two. In other words, it's saying that Robin has a property of redbreast. Whereas here, it's showing a different kind of relationship between concepts. It's saying Robin is a bird. It's not saying Robin has a bird or has a property of the bird. So there are two kinds of pathways. One is called the property pathway, and the other one is a membership pathway. Now, depending on the kind of property pathway that connects two concepts in a given proposition, there are two kinds of propositions: property proposition and membership proposition. A property proposition has two concepts, Robin, redbreast, connected by a property pathway. So Robin has redbreast, then is a property proposition. The other proposition is the membership proposition. Example here is the bird is an animal, right? It has two concepts, bird and animal, and the pathway here is the is a pathway. So there are two kinds of propositions. Now, propositions are also called statements, idea units, or statements, propositions. So property statement or property idea unit, property proposition, they all refer to the same thing, proposition of a property kind, and same thing applies here. Okay, so we're talking about the structure of the semantic memory one. And we said that structurally, semantic memory is basically a network of concepts or network of propositions of different kinds. And we have two types of propositions. Well, remember we said that we're gonna come back to this handout and fill these blanks. Well, this is the time to fill it now. Now we already know this is situational knowledge, but structurally we said that semantic memory, because it applies to both, is basically made of concepts. Guess what goes here? Come on, think, you can do it. Yes, it's propositions. So structurally, semantic memory consists of concepts and propositions. It's actually a network of concepts and propositions. Now we're going to move on to the processing aspect of it. And you can see the three important things we need to know about the processing aspect, like how do we process information in a semantic memory, which is basically structurally is a network of concepts or network of propositions. And we know one concept, which is concept activation, but we'll talk about the other two as well. Okay, so structurally we know what semantic memory is. Now processing wise, how do you process information? Or another way to look at it is what happens when you read an idea, a sentence, a simple idea. Well, to understand that, first thing you already know, first thing that happens is concept activation. In other words, whatever concept you're reading, right, that gets activated. If I say Robin, that gets activated. And the activated concept is shown here in bold letters, right? So there is one concept in your mind right now that is in non-bold letters, and it will get active once I say or take the name of that particular concept. Are you ready? Okay. Chocolate. Okay, that particular concept was inactive. It became active the moment I use the term. So the first thing that happens when you read about a concept or hear about it, either as a concept in itself, like for example chocolate, or as a part of a sentence, my friend gave me a chocolate, is that it gets activated. So the first thing that happens is concept activation. Well, that was the first point, right? Remember the handout? Now what happens next? Well, whenever a concept gets activated, well, that activation spreads. It's called spread of activation. Just like if you drop a stone in a still water, what happens? There is, yes, a ripple, right? And that ripple continues for a while. That's exactly what happens here. Whenever a word or a concept is activated, right, it actually leads to spread of activation, which basically means that other connected concepts get activated as well on its way of spread of activation. And this spread of activation, it spreads for some time, right? Just like this stone in the still water, the ripples are formed and the ripples stay for some time, but it will never ever go on forever, right? So it only is active for some time. In the process of this spread of activation, what is happening is that the relevant and related and closely linked concepts also get activated, but not the ones that are too far. So first one is concept activation, the second is spread of activation, right? So if you remember, concept activation and spread of activation. Now we need to know what this third one is. Well, the third one is, for instance, if you're reading a sentence or an idea like Robin has wings, right? There are two spreads here. One spread that starts from the concept Robin, right? The other spread that starts from the concept wing. If you say President Trump, Trump is the 45th president of the United States, those two concepts get activated, right? So, and those two concepts that are activated, right, concept activation, the second step is this activation spread. Well, right? And the next thing that happens is that these two activations, these ripples will intersect. It's called surge intersection. Surge intersection is where spreads of activation from two different concepts meet. That means you have comprehended the sentence. So we said that the process of accessing information in semantic memory has three parts to it. The first one is concept activation. The second part is spread of activation. The third part is search intersection. Right now, it is important, and this particular idea was tested, and is being tested in different theories. And one way they test these theories, and I just imagine that. Just keep in mind that semantic network is just one of the models, and there are several others with other criteria of how and other explanations about how the semantic memory is structured and processes information. One prediction of this model, semantic network model, is that there is faster reaction time for concepts that are closer and slower reaction time for concepts that are far away, right? So in fact, there is enough evidence to support this particular model. Again, there are some specific things that this model is not good at predicting, and that's why we have other models. But again, just to give you an idea, that faster reaction time for closer nodes, because the concepts are closer, then the ripples will intersect immediately. So people will be faster to respond to a sentence that has concepts that are closer to one another, as opposed to a sentence that has concepts that are far apart. Well, okay, to sum up then, we talked about semantic memory, and we said there are two types of semantic memory: conceptual and what's that? Yes, situational, right? And process, in terms of structure itself, semantic memory is a network of concepts or network of, one more time please, yeah, propositions. And processing wise, the first thing that happens is concept activation, and the second thing that happens is, I can't hear you, yes, spread of activation. And the third thing that happens is, one more time, I can't hear you, louder please, search intersection. That's correct. So concept activation, spread of activation, and search intersection. Well, we are done with the basics of semantic memory. We're also done with semantic memory 1. The only thing that's left now is to talk about semantic memory 2, which we will in the next video. The semantic memory 2 is basically situational knowledge. And in that context, we'll talk about schemata and scripts. The idea is simple. If we have concepts for objects that we experience, do we have concepts for situations? Well, by now you should know that we do. So we have situational concepts, and those are given different names, but the idea of situational concepts or situational knowledge is pretty much same. You have concepts and you have propositions, but the concepts are not about objects, but the concepts are actually about situations. Okay, so in the next video we'll talk about schema, or schemata, and scripts. Thank you, stay tuned.